We are continuing with the KEYTER Academy capsule videos on the basic components of a heat pump, and we are going to explore the electronic expansion valve in this session. To understand how the electronic expansion valve works well, you must see the thermostatic expansion valve, a video that we already have uploaded on the network to understand how the electronic expansion valve really works. It works like a thermostatic expansion valve, but the difference is that it works electronically by measuring pressures and temperatures, so its management is much faster, and it has a series of advantages over the thermostatic expansion valve, which, as we already said, was slow in its operation due to the way it is constructed. The advantages that electronic expansion valve has over the thermostatic expansion valve are that thermostatic valves are only suitable for one refrigerant. The bulb is charged with a refrigerant, so that is what controls the thermostatic expansion valve, and it is only suitable for one refrigerant. Thermostatic settings are considerably more complex. Their fault analysis is also more intricate, and electronic expansion valves have a significantly faster measuring capability. If you remember, the thermostatic expansion valve had a pressure, the bulb pressure that depended on a temperature, the temperature that the bulb in the suction discharge, in the evaporator discharge, with which that way of heating that gas and that way of transmitting the pressure is slow. In addition to having a pressure translator for instant data transmission, the electronic expansion valve does not need the balancer that was previously used to compensate and verify the accurate measurement of the bulb during strong pressure drops in the evaporator coil. This feature simplifies the system and improves efficiency by eliminating the need for an additional component. We have two types in this case because we have one at 90 degrees where, depending on the instructions given to the electronic expansion valve, it can either open the passage by a certain percentage or close the passage of the refrigerant fluid, thereby causing a variation in the power of the equipment. In this particular scenario, the valve is closing due to a short overheating issue, and to address this, we need to prolong the overheating by reducing the flow of refrigerant. By doing so, we can effectively manage the temperature and prevent further damage to the system. This adjustment is necessary to maintain the optimal performance and ensure the longevity of the equipment. Another typology we possess of electronic expansion valves is in line, and they operate in the same manner, always measuring the pressure and temperature to establish what the overheating of the equipment is. This information is crucial for regulating the flow and ensuring optimal performance of the system. To determine equipment overheating, we use an electronic brain, a regulation that measures evaporator discharge pressure with a pressure transducer. This helps us know the operating pressure. We also employ one temperature probe at the evaporator discharge to determine the temperature before it reaches the compressor. This allows us to monitor and prevent overheating. The electronic brain acts as a safeguard by providing real-time data on the discharge pressure and temperature, enabling us to take necessary measures to maintain optimal equipment performance and prevent potential damage caused by overheating. Well, upon analysis, it is evident that the team is well informed about the refrigerant we are working with. We have provided them with the necessary information regarding the specific refrigerant we have to work with, including details about the complete hood and the entire Moliere diagram. By knowing the pressure, they are able to determine our location, and they also possess knowledge of the saturated vapor temperature at the evaporation pressure. Utilizing a temperature probe, they can accurately determine the temperature at which we are discharging the refrigerant gases from the evaporator. As a result, the measurement of the superheat, which is the difference, is obtained directly. As you can observe, this is significantly faster than the thermostatic expansion valve, so as we previously mentioned, working with an electronic expansion valve is essential for eco-design or inverter equipment issues. Well, that's it, and we'll see you in the next video for more information and further insights. Thank you for watching.